Hello, it's Keith here, and this is lesson 26 of the simple series of my Z80 assembly programming tutorials. In this series, we're looking at various simple examples, and today we're looking at the Elan Enterprise. Now, we're extending the previous bitmap example, and we're adding clipping. What does that mean? Well, if you look at my code here, if I find my joypad, well, when we moved around before, we could move around the screen, but now we can go partially off the screen, and we can go partially off the screen in all directions here. You may notice the Chibiko is a bit of an odd color today. This is the alternate color version because this is using an XOR Sprite routine, and we've cleared the screen to white so that we can see the area of the screen that is actually clippable, so we can tell that the clipping is working correctly, which it is. Now we're going to look at today's example in two lessons. The first lesson we're going to look at the clipping routine and the basic Sprite routine, and then we're going to look at some of the other tricks we can do. You see, we're doing two tricks today to speed things up and make them nicer. Firstly, we're using stack misuse. This is a way of misusing the stack pointer for fast reading and writing. We are doing that. Well, actually it's disabled for this example, but we can turn it on. The other thing we're doing is we're using two screen buffers so that we don't get any flickering as we're redrawing, and we're going to be looking at those next time. So that's what we're going to be doing today. Now, before we go into the code itself, we need to discuss the theory. It's the same every time, but I don't assume if you watched all of my other videos, so we're going to have to quickly go over it again. So the first thing we need to discuss is the clipping algorithm that I'm using. So basically, we are using a coordinate system which I refer to as logical units, and these are mapped to the physical pixels. So basically the problem is, our screen on this system is about 256 by 192, at least in the screen mode I'm using. We want to work with single byte coordinates, but we need an area of the screen, an area of the coordinate system that's off the screen. So the 0 to 255 range of our coordinates needs to include parts that are off the screen, and our screen is 255 pixels wide. What are we going to do? Well, what I do is quite simply I divide everything by 2. So our 256 by 192 physical screen becomes a 128 by 96 logical unit screen, and then we just center this within the 255 by 255 range. And so basically, if you see this screen here, this is the visible screen, this light area. The dark area around this is the invisible screen, and our Chibiko here, positioned in this coordinate here, will only be partially visible on the screen, and the rest will be cropped off. So that's how I do my logical coordinates, and how, as I say, basically if you want to think pixels, you just need to double the logical units to get the pixel coordinates. If you want to convert pixels to logical, you just divide by 2. Pretty straightforward. Now, what about this cropping routine? Well, it's the same cropping routine I use every time, but basically we've got our screen here. If you think of our screen, this is our screen. And then we've got our sprite, so this is our sprite. And our sprite is going to happily move around the screen until it gets to a point where it's not entirely on the screen. And then we're going to need to do some cropping. So if our sprite goes off the top of the screen, we're basically going to need to do two things. So basically, we're going to need to change the height of our sprite to this area here, and we're going to need to skip the source bitmap data for this area here, and we're going to need to change our Y position to 0 here. That's what we would do if we go off the top of the screen. But of course, off the left hand side of the screen, well, this is all different. We're going to need to skip this first part here. We're going to need to change the width, and then after each line, we're going to go horizontally and then vertically. So after each line, we're going to need to skip this part as well. Now, that's on the left, but on the right, it's different. We won't need to skip any of the first bytes, but we will, of course, need to change the width again, and we'll need to skip the part after each line. Off the bottom of the screen, well, different again. So we don't need to skip any bytes, but we need to change the height of our sprite and skip the bottom part there. Of course, the big challenge is, though, this could happen at multiple. We could be off two sides and we need to do two things. So the code has to cope with that as well, and it does indeed cope with it. And it didn't in Chibiakuma's. There was a bug in the code. The clipping algorithm I basically created almost by trial and error because my maths was very poor. It's slightly better today, so the code does work, hopefully. So anyway, so that's the algorithm we're looking at today. I'm in no way saying it's the best algorithm. I am pretty certain it's not the best algorithm, but it works and it's available for you if you want to use it. And I've ported this example to a large number of different systems, not just Z80 ones as well. So if you're looking to do multi-platform programming and you want to write something that works on multiple systems, you know, it's there and it's free for you to use in any capacity you want. And as I always say, I don't believe you could use it commercially, but if you somehow manage to do it, you're welcome to do so. So say it's free for your use. Now, we're not going to look at the main code that was in the other Simple Series example. If you look at the joystick and the sprite examples I've done in the Simple Series in the past on the Enterprise, I've covered the screen setup, the reading the joystick. I'm going to assume you know how to do all of that yourself, or you're going to research it. So we're just going to look at the modified draw sprite routine and the do crop routines today. So we're working at all times in logical units. So our pixel size of our Chibiko bitmap is 48 by 48, but we're defining the width and the height in H and L here as 24 by 24 because that's logical units. We're setting our source bitmap data in IY as test sprite, and we're running this do crop routine, which calculates any required changes to the width and the height, the X and the Y position. The X and Y position are in B and C, and they're in logical units as well, and it will update the source bitmap data as required as well. Now it will set the carry if the sprite is entirely off the screen, in which case we're just returning and not doing anything. If we do need to do anything, we're going to calculate the screen position of the VRAM destination, and we're going to run the show sprite routine, which is a slightly modified version of the original. We'll have a look at that in just a moment. First of all, let's take a look at the do crop routine. So here's the do crop routine. So at the start of this routine, X and Y are in B and C in logical units, width and height are in H and L in logical units, and IY is the memory address of the source bitmap data, which may need changing if parts of the sprite need cropping before the drawing starts. Okay, we use D and E as temporary variables here, and we're going to consider basically our sprite. If we imagine this as our sprite, we're going to consider the top and the bottom cropping first, and we will alter everything accordingly, and then we'll do the left and the right second. So we do it in 2 stages. So D and E are our temporary variables, and we're just setting those to 0 to start. What we're doing here is we're loading the Y position, and we're subtracting the minimum logical unit that is visible on our screen, and we define this at the top here. So this is basically the top left effectively of our visible screen in logical units. So that's what we're doing here, and so this is effectively going to take our sprite, and it's going to, if our sprite is partially off the screen like this, that is going to convert our Y position into a negative value. Now if it's not converted to a negative, we don't need to crop the top. If it has, we flip it back from a negative back to a positive, and this is now the amount we need to remove from the top of our sprite. So we're now comparing it to L, which is the height of the sprite, because if the sprite is completely off the screen, this will be more than the height of the entire sprite, and so in that case we need to give up. So we're jumping to all off screen. All off screen simply sets that carry and returns. There it is, just sets the carry and returns, and that tells the calling routine to give up. There's nothing to do. Important because firstly it would be a waste of time, and also if you try and draw a sprite of 0 height, you might end up in a very large or infinite loop, and that might corrupt memory and things. So we are giving up in that case. Otherwise, we've now calculated the amount to remove from the top. So we store that in E. We are setting A to 0 here, and that's because that is the new Y position. That's because we need to start drawing. If we are partially off the top of the screen, we're going to need to skip some of our sprite, but we need to start drawing from 0 there. So that's why we are doing that. We're storing the new Y position in C here. We've now subtracted the minimum, and so we're one step closer to a physical line number. We're still in logical units, but we'll convert that later. So we've done the top, we're now doing the bottom. So we're adding the height of the sprite, and we are now comparing to the height of the screen in logical units here. And we are seeing if we have caused an overflow here. Now, if we have not done that, then we are effectively must be partially off the bottom of the screen, like something like that. So we are now checking the number of lines that are off the screen, and again, if it's the entire height of the sprite, nothing to draw, so we want to give up. But otherwise, we're storing the amount to remove from the bottom in D. So we've got the amount to remove from the top in E, the amount to remove from the bottom in D. We are then adding the two together and seeing if there's anything to remove in total, and if not, we're skipping it. Otherwise, we are just converting this, negating it, and then adding it to L. This is effectively subtracting the amount to remove from L. L is now the new height with anything to remove subtracted from it. Okay, now we've now converted the height, but if the sprite is partially off the top, we might need to skip something like Chibiko's head in that case. So we need to update IY with the amount to remove from the top. So what we're doing here is we are taking the amount to remove from the top into the accumulator here. We are then taking the width of the sprite in logical units, which is effectively actually coincidentally the number of bytes for each pair of lines. And so we are then repeatedly adding this to the source memory address until A reaches 0. And so this is effectively skipping all of the lines that are needing to be removed, working in logical units there. So that's what we're doing here. That it's just a simple multiplication routine, basically, effectively skipping those lines there. We're now actually done for the top and the bottom crop. We're going to repeat the same procedure for the left and the right. So we are now setting D and E back to 0. We're then taking the X position, subtracting the minimum X, and so we're effectively now considering maybe the sprite somewhere like this, and if the X position has gone negative, then it is. And so that's what we're going to do here. So we're now, if it's not gone negative, there's nothing to crop on the left. Otherwise, we are negating it, converting it back to a positive, comparing it to the width of the sprite. If it's the entire sprite or more, then we don't want to draw anything. Otherwise, we are setting our left crop here. Now, we do have some code here for stack misuse. Now, basically, if we are using stack misuse, we are working in pairs of bytes, and so we've got some corrections here to effectively round things up here, so that we are working in pairs of bytes, and then we are updating the new draw X position. I'll just show you that actually. We just enable this. This code will work with or without stack misuse. So we will just run the code again with stack misuse enabled, and I'll show you the difference. Okay, so here's the program. Here's my joypad, and now if I start moving to the left of the screen, you will notice, you can see there that everything looks normal, but then if I move a little bit, one strip has disappeared, and this is because we are working in pairs of bytes. We're using the stack pointer, and that has to work in pairs of bytes. And so when we've got an offset of 1 there, we can't load in a pair of bytes and draw it correctly, so we're effectively missing one strip there. The stack misuse routine isn't necessarily so practical for clipping the sprites, but you know, for completeness, I wanted to make it all work, and so we've got this code here to make that correction as required for when the sprite is partially off the left hand or the right hand side of the screen here. So that's what we're doing here. We're then storing the new X position, and we're now considering the right hand side. So we're adding the width of the sprite, we are subtracting the entire logical width of the screen. If this has caused a carry, then there is nothing to remove from the right hand side. Otherwise, we must be partially off the right hand side of the screen. Something like this. So that's what we're doing here. We're then comparing to the width of the sprite, and if it's more than the width of the sprite, then we're all off the screen, so we're skipping off. Otherwise, we are storing D with the new amount to remove from the right. So E is the amount to remove from the left, D is the amount to remove from the right. We're adding those together. We're converting to a number of bytes, because we need to work in bytes, of course. We can't work in logical units. There's 4 pixels per byte, but there's 2 pixels per logical unit, so we're dividing by 2 here, and that is converted to a number of bytes. If stack misuse is enabled, we're working in pairs of bytes, so we've got a modification here. If there's nothing to crop, then we're skipping, but otherwise we're going to need to set the amount to remove after each line, and we're using self-modifying code here, setting sprite hclip plus 2 to the amount to skip after each line, because whether we're off the left hand or the right hand, after each line of our sprite, we need to skip a couple of bytes of our source bitmap data before we draw again. So that's what we're doing there. Now that we've got the number of bytes to remove, we're now converting this, and we are adding the width of the sprite, and this is effectively recalculating the width for the crop to be removed. What we're now going to do is calculate the amount to remove from the left hand side of the sprite, because we need to now skip any source bitmap data before we start drawing, because again, if you think of like this fireball here, if we're on the left, we need to skip that before we start drawing anything. So that's what we're doing here. Now D is now no longer needed, and so we're modifying in our clipping routine here. This is defining to use this alternate clipping version, which will skip bitmap data after each line of our sprite is drawn. Again, we got a line for the stack misuse here because we're working in pairs of bytes. But basically what we're doing here is we are skipping any bytes from the left hand side if our sprite is partially off the left hand side of the screen. We're adding that skip to IY here, and that is now basically finished. If we're not clipping on the left hand side or the right hand side, we are setting the default get next line routine. The last thing we're doing here is we are converting our logical units to physical ones. So X and Y need to be converted. The X position and the width need to be converted to bytes, and we're doing that by shifting these to the right by 1, effectively dividing by 2. So instead of working in 2 pixels per logical unit, we're working in 4 pixels per byte, so we're dividing by 2 here. The height and the Y position we want in lines, and so we're effectively doubling, because the logical units were 2 pixels per logical unit, but we want them in single lines, so we're multiplying that by 2. We're then ORing A, and this is to clear the carry, and that's to tell the calling routine that there's stuff to draw, get drawing. Okay, so let's have a look at the draw sprite routine. Okay, so here is the regular one without the stack misuse. We'll look at the other one next time. So we've got our calculation routine to get the screen position. So here it is. This is effectively calculating. We're just effectively multiplying the Y position by 64 bytes here and adding the X position. Our screen base is C000. So that's being calculated here. Our sprite drawing routine is basically just transferring data. We've got our source bitmap in IY, but we're moving it to DE for speed here. So we're repeatedly XORing the source bitmap data with the screen. We're increasing the memory address of the source bitmap data and the VRAM destination here. We're repeating until we've done a line. We're then running our get next line routine, and that will be self-modified, altering that if we need to clip after each line. If not, we just repeat until we're done. Now the get next line routine simply adds 64 hexadecimal 40 to the VRAM destination, effectively moving us down a line after each line. So we go across, move down, go across, move down, go across, move down until we've drawn our sprite. But if we need to clip on the left or the right, we need to skip some bytes, and so we're adding the bytes to skip to DE after each line has been drawn, and so we would self-modify in. Instead of running get next line, we would run get next line with clip, and we self-modify in by changing this jump, and that's why this label afterwards is specifying +2, because if we subtract 2 we get the memory address of the line that's being jumped to. Now the line here looks like it's adding 0 to DE because that HL is being loaded with 0, but that's self-modified. This get sprite hclip +2 is being self-modified by the do crop routine, and that is the amount of bytes to skip after each line. So it's being changed by the time the code actually runs its self-modifying code. It's faster, it saves a little bit of memory, but it is a bit confusing to read. But this is a heavily optimized version of the code, so I'm afraid you have to kind of cope with this kind of thing. Now, of course, if you're finding all this a bit daunting, then I would always recommend you simply don't use cropping. Think of a game that doesn't need it. There's plenty of them out there. But as this is I think it's a reasonably usable piece of code. It's based on the one that I wrote for the Suck Hunt game. That was a horizontal scrolling game, a bit like Operation Wolf. It was stereoscopic. It was a bit of fun, but I enhanced the game because the code that game only scrolled horizontally, so it didn't have the vertical crop. But I added vertical cropping, and I've ported this to various systems, and you can get the source code from my website. Anyway, hope you've enjoyed what you've seen today. Thanks for watching, and goodbye.